History has a way of repeating itself, but in the case of the United States Navy, it prefers to evolve. For over half a century, the name Enterprise was synonymous with the sheer audacity of American naval power. The Big E CVN-65 was the world's first nuclear-powered aircraft carrier, a vessel that served through the Cuban Missile Crisis, Vietnam, and the War on Terror before finally restoring its reactors in 2012. Now rising from the dry docks of Newport News shipbuilding, a new titan is taking shape to reclaim that legendary mantle. This is the USS Enterprise CVN-80. She is not just a replacement, she is a generational leap. As the third ship of the Gerald R. Ford class, she represents the apex of maritime engineering, a 100,000-ton nuclear-powered fortress designed to project air power to any corner of the globe for the next 50 years. When she finally slips into the water, she is expected to become the most capable warship ever constructed. The resurrection of the Big E. The story of CVN-80 is deeply intertwined with the emotional and tactical legacy of her predecessor. When the original nuclear enterprise was decommissioned, it left a void in the fleet and in the hearts of naval aviators. That void was officially filled on December 1, 2012, when the Navy confirmed that the ninth ship to bear the name would be a Ford-class carrier. Construction began not with a bang, but with a ceremonial cut of steel in 2017, followed by the laying of the keel on August 27, 2022. But this wasn't just any steel. In a symbolic gesture linking the past to the future, 35,000 pounds of steel salvaged from the scrapped CVN-65 were melted down and forged into the hull of the new CVN-80. The DNA of the Big E is literally welded into the bones of the new ship. Adding to this lineage of excellence are the ship's sponsors, Olympic champions Katie Ledecky and Simone Biles. Their initials have been permanently welded into a steel plate within the hull, cementing a connection between American athletic dominance and American military might. As of late 2025, the Enterprise remains under active construction at Newport News Shipbuilding in Virginia. While delays are common in projects of this magnitude, the latest Navy budget projections target a delivery date of July 2030. When she arrives, she will be the first aircraft carrier in U.S. history built primarily using digital tools rather than traditional paper blueprints, a paperless ship born from a fully digital development process.
The anatomy of a monster. To call the CVN-80 big is an understatement. She displaces approximately 100,000 long tons at full load. She stretches 337 meters, 1,106 feet from bow to stern, with a beam of 41 meters at the waterline and a sprawling flight deck measuring 333 by 78 meters. She draws roughly 12 meters of water, requiring deep harbors to berth. Powering this floating city are two advanced A-1B nuclear reactors. Unlike the complex 8-reactor design of the old Enterprise, these new plants are marvels of efficiency and raw output. They drive 4 shafts, propelling the massive vessel to speeds in excess of 30 knots. More importantly, they provide effectively unlimited operational range. The Enterprise can circle the globe repeatedly without ever needing to refuel her engines. Her only tether to land is the food for her crew and the fuel for her jets. Speaking of the crew, the Enterprise is a bustling metropolis at sea. Her total complement, including the ship's company, the airwing personnel, and the command staff, is expected to reach approximately 4,660. While this is a massive number, it is actually fewer than the Nimitz-class carriers, a reduction made possible by extensive automation. The digital flight deck, changing the game. The true lethality of the Enterprise lies not in her hull, but in her systems. As a member of the Ford class, she introduces technologies that fundamentally change the rhythm of naval aviation. The most critical of these is the Electromagnetic Aircraft Launch System, EMALS. For decades, carriers relied on steam catapults, violent, maintenance-heavy systems that punched aircraft into the sky. EMALS replaces steam with electricity. Using linear induction motors, it accelerates aircraft more smoothly and with precise control. This reduces stress on the airframes, extending the life of the jets. Crucially, it supports a wider range of aircraft weights, from heavy, bomb-laden strike fighters to the light, fragile, unmanned drones of the future. Complementing EMALS is the advanced arresting gear, which uses software-controlled electric motors to catch incoming aircraft. Together, these systems enable a significantly higher sortie generation rate, the ability to launch and recover more planes in less time than any previous class of carrier. The flight deck itself has been redesigned. The island superstructure has been moved aft and made smaller, creating more deck space for parking and maneuvering aircraft. Advanced weapons elevators moving on magnetic rails transport munitions from the magazines to the flight deck faster and more safely than the old cable-driven elevators. This pit stop philosophy means aircraft can land, rearm, refuel, and launch again in record time.
The fist of the fleet, the airwing. Offensively, the Enterprise is a mobile airbase capable of hosting nearly 90 aircraft, though a typical deployment will feature more than 75. The airwing of the 2030s will look very different from today's. It will likely feature the F-35C Lightning II as the stealthy tip of the spear, penetrating enemy air defenses. Supporting it will be FA-18 Super Hornets, or their replacement, the FA-XX, EA-18G Growlers for electronic warfare, and E-2D Advanced Hawkeyes for battle management. However, the Enterprise is purpose-built for the unmanned revolution. Because she was designed digitally with expanded growth margins, she has the electrical capacity to support future systems like the MQ-25 Stingray aerial refueler and the Collaborative Combat Aircraft, CCA, drone wingmen that will fly alongside manned fighters. She is also future-proofed for directed energy weapons, lasers, that require massive amounts of electricity, something her A-1B reactors can provide in abundance. Global Titans, how she compares. In the arena of global naval power, the CVN-80 has few peers. Her closest rival is China's Type 003 Fujian. While an impressive leap for the People's Liberation Army Navy, the Type 003 is estimated to displace between 80,000 and 85,000 tons, considerably less than the Enterprise. The Type 003 utilizes conventional propulsion, steam turbines fired by boilers, meaning she must carry massive amounts of fuel for her own engines, limiting the space available for aviation fuel and munitions. The nuclear-powered Enterprise suffers no such limitation. The United Kingdom's Queen Elizabeth-class carriers are modern marvels, displacing around 65,000 to 70,000 tons. However, they are built around short takeoff and vertical landing with the F-35B. While flexible and excellent for expeditionary warfare, they lack the catapults and arresting gear necessary to launch heavy airborne early warning aircraft or long-range tankers, limiting their standalone strike reach compared to a Kato-bar supercarrier like the Enterprise. Even France's Charles de Gaulle, the only other nuclear-powered carrier in the world, is dwarfed by the CVN-80. Displacing roughly 42,000 to 45,000 tons, she is less than half the size of the American giant. Her smaller air wing and limited magazine depth reflect late 20th century design philosophies, whereas the Enterprise incorporates 2 additional decades of technological advancement.
Despite her technological dominance, the Enterprise is not invincible. The most immediate enemy is cost. A single Ford-class carrier requires roughly $14 to $15 billion to construct. This figure excludes the cost of the aircraft on her deck and the billions required for lifetime operations and maintenance. In an era of tight budgets, she is a massive investment. Furthermore, a carrier is a large target. Without her escort ships, destroyers, cruisers, and attack submarines, she is vulnerable to long-range anti-ship ballistic missiles, quiet diesel-electric submarines, and cyber attacks. While her defensive suite includes rolling airframe missiles, RAM, evolved Sea Sparrow missiles, ESSM, and Phalanx CIWS, her survival depends on the integrated strength of the entire carrier strike group. Logistics also remain a tether.
While her reactors run forever, her aircraft drink jet fuel and expend munitions at a terrifying rate. During high-tempo operations, the Enterprise requires a constant conga line of supply ships to keep her magazines and fuel tanks topped off. As the calendar inches toward 2030, the USS Enterprise CVN-80 represents far more than just another hull number. She is a statement of intent. In a world of resurgent great power competition, she is a mobile, sovereign airfield that can park off the coast of any nation and dictate terms. With her immense displacement, unlimited nuclear endurance, and ability to launch the next generation of manned and unmanned aircraft, she is poised to redefine how carrier warfare is conducted. The Ford class had a rocky start with teething issues on the lead ship, but the Enterprise benefits from the lessons learned. She is the mature, lethal realization of the concept. When she finally sails, the ghost of the Big E, the ship that fought the Cold War, will be sailing with her, welded into her steel. But the CVN-80 is looking forward, ready to carry the torch of American sea power into the uncertain waters of the mid-21st century.
Enjoyed the episode? Like and subscribe to Military Forces. For more in-depth content, your support helps us create more.